Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about interrupt vectors. See, we already learned that we have an 5 interrupts, that is external interrupt 0, timer 0, external 1, timer 1 and serial interrupts. So timer 2 will be available in 8052. So we need to have some vector test because we already know that whenever interrupt occurs, that interrupt service routine will be executed. How that interrupt service routine will be executed? By using this interrupt vector address. So each interrupt we allot some locations. So whenever that interrupt occurs, that corresponding location program will be executed. Look at this. Each interrupt we specify some location. Look at this. External interrupt 0, we use this 0003H. Again, timer 0 also we use 000BH. Then external interrupt 1 0013. Timer 1 overflow we use 001B. Serial interrupt we use 0023. Timer 2 is not available in 8051. If you go with 8052, it is available. So we use this 002B. Look at this. We don't have a much location to store the interrupt programs. So look at this. This is a 3 and this is B. So in between we have only 8 memory locations. So within that 8 memory location, it is not possible to write a complete programs. So what we do, we use some jump instructions. So once interrupt, for example, external interrupt 0 is occurred. Once external interrupt 0 is occurred, so this corresponding location will be loaded to program counter. The program available in this location is started executing. What we do, we put a jump from this location to some other location. So actual where interrupt service routine is available, that is where ISR is available, that location will be loaded in this 0003. How we load means jump instruction followed by that particular address. What happens once interrupt occurred, so this location will be comes. So here we have jump to some particular ISR location. So there it jump from ISR location, that programs will be complete. After that we have an interrupt, return from an interrupt, it go for a main program execution. So similarly for all interrupts, so we use only 8 locations will be available. If the interrupt service routine program is less than that 8 location, we can use here itself. If it is more than 8 locations, so we need to jump from this location to some other location. So we can put it in a 4000 or 5000 any location. So we simply here we just put D3, that is a jump, that particular location address. So 4000 means 0040. And then to avoid overlapping of this, that is in the same locations cannot be used, no. So that's why to avoid overlapping, we use this jump. Look at this example. So origin 009B, we are jumping from this L jump external interrupt ISRs. So what happens? These location will be jumped and then the program will be executed. Where we have this, look at this. So this is an EX7 ISR. So look at this. This is EX7 ISR. So it jumps L jump to this interrupt. So we have here as an interrupt service routine programs. After completing this interrupt service routine program, we have the instruction RETI. So once this RETI instruction, it go for a main programs. So actually normally it execute this main program. Once this interrupt occurred, it go for that particular interrupt location. So that is the interrupt vector address. Look at this. Which interrupt occurs? Because we have so many interrupts. So which interrupt occurs, that corresponding location only will be loaded to the program counter. That corresponding location program will be executed. So for example, if the timer 1 overflow occurs, so this 001B will be loaded to the program counter. There we have a jump to that timer 1 overflow operations. So we complete the timer 1 overflow operation. Again we have the return interrupts. So return, once we receive that interrupt, it will jump to the main programs. Look at the examples for this. So this is an interrupt service routine. This is an ISR blink. So here we have the interrupt routines. Look at this. Push program status wait. Program status wait will be pushed into stack. Again we are loading this move program status wait, 18. So here the data present in R0 to R7 should not be affected. That's why we are normally working in a bank 0 now. Now we are jumping to bank 3. We can jump to bank 1, bank 2 or any bank. So to avoid the already computed data should be overwritten. Look at this. Again, we are loading the value. Move R0, comma 10. Move R7, comma 2. And then move R6, comma 0, 0. Move R5, comma some values. So this is for a simple delay calculations. So just inner loop. So decrement jump on 0 R5, comma this instruction itself. So that's why putting this not as simple. So this instruction will be repeated till this R5 times. After this is an inner loop. Outer loop will be R6. So R6 times this inner loop is repeated. So this is an inner loop. Outer loop, this is an R7. So these two loops, this is an R6 loop and R5 loop will be repeated in a R7 times. Again, these three loops, there is an R5 loop, R6 loop and R7 loop. This will be repeated R0 times. After completing this, we have an things complement P1.6. So we are connected an LED to this P1.6. So this data will be complemented. So after that, again we have this degenerate R0, again loop 2. So this will be that is R0 time, it will be repeated. After completing, we are pushing that program status word now. We need to pop up it. That's why pop program status word. Again we have the instruction of RETA, that is a return from an interrupt. So once this interrupt occurred, RET instruction received, so it will go for a main program. Thank you.